All right, ladies and gents, you are going to be actually getting your problem set and working with that to start. If you go to the very back, you're going to see that there's a template, and that's what we're going to be working with today. On this template, we're comparing two different models. One model represents tenths because there are 10 pieces, and one represents hundredths. They both are a whole, but this is hundredths, and this is tenths. All right, so this way we can actually compare two things that are the same size, but they're just broken up differently. So the first thing we're going to have you do is I'm going to have you color in 1/10 and 10 hundredths. So please color in 1/10 and 10 hundredths. Pause while you do it. So you should have come up with 1/10 and 10 hundredths. If you went sideways, that's fine. The only problem is it's hard to compare them if they're not exactly going the same direction. What can I say about 1/10 versus 10 hundredths? Well, hopefully you can say that they are equal, because 1/10 shades in one whole section and 10 hundredths does. Now you may be able to use your eyes to see that, but we're going to use math as well. We are going to ask ourselves, how do I get from 1 to 10? And the answer is 1 times 10 gets us there. What I do to the top, hopefully you're saying I do to the bottom. So I bring over my 10, and I say 10 times what gets me 100? Well, it's 10 times 10. I do the same thing on top and bottom to get the same equivalent fraction. So 1/10 is 0.1, 10 hundredths is 0.10. They are exactly the same. This just has an extra 0 in the hundredths place. This does not have a 0 in the hundredths place. Let's go ahead and try another one. I would like you to compare 3/10 versus 30 hundredths. See if you can figure out, using math, if they are equivalent. Pause while you do this. This is what you should have gotten. You should have shaded in 3/10 and then 30 hundredths. 10, 20, 30. And then you should have said 3 times what gets me 30? And it's 3 times 10. What I do to the top, I do to the bottom. Bring over my 10. 10 times 10 is 100. They are actually equal. All right. If you need these when you're doing your problem set, you can go ahead and use them. The next thing we're going to do is we're going to actually look at the number bonds and discs. So what I'd like you to do is I'd like you to turn to your problem set, and I would like you to look at problem number 3. Number 2, you can cut this the way you need to in order to turn it into tenths and hundredths, just like we did here, tenths and hundredths. Circle hundredths to compose as many tenths as you can. Well, we just found out that there is 1/10 in 10 hundredths. Complete the number sentences. Represent each with a number bond as shown. So how many hundredths do I have to count up to equal a tenth? Well, you should have said 1. No, you should have said 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this right here is 10 hundredths. But we know that 10 hundredths is the same as 1/10. So this really equals 1/10. And we proved it right back here. 1/10 is 10 hundredths. So how many hundredths do I have total originally? Well, I had 12 hundredths. But once I broke them down, how many tenths did I have? I had 1/10, and I have 2 hundredths left, which looks like 0.12. 1 is in the tenths, 2 is in the hundredths. 1/10, 2 hundredths. That's how you write your number bond. If you go to number 4 on your problem set, they're just asking you to turn the fraction into a decimal. That's all you're going to do. And, obviously take your time with it and make sure that it makes sense. Remembering your spaces, your number that comes before the decimal is your whole number. Then you have a decimal. Then you have tenths Then you have hundredths, tenths, and then hundredths. They are spaces. So maybe write that down to help yourself out. You're going to get together with a partner and work on this problem set together and finish it up, and then you can go on to homework. It shouldn't take you that long since we covered this piece and we talked about this piece up here. And we've already actually done this one. All right, good luck.